Welcome, my name is John Casey. I'd like to welcome you to the Open House Dublin tour of CHQ, Virtual Tour 2020. I have a presentation that I'd like to give on the history of the CHQ building and my involvement with it. I've been involved with the CHQ building for 20 years now, since 1999, year 2000. So I'd like to share some of the insights I've gained over those 20 years with you today. This is the building in its current state. This is it when it was completed, and as you see it now if you walk up to the building. And to tell you where it all started, back in 1818, the building was commissioned by the Dublin Port and Docks Board. They commissioned two warehouses. The one on the right is actually the CHQ building. On the left, there was Stack B and Stack C. Stack B isn't there anymore. Stack C is still there and in place and now an office building. And the idea was that the Dublin Port and Docks Board wanted to build bonded warehouses here to store whiskey and tobacco. This is the first drawing that we're aware of that was done of the building. It was unearthed only a few years ago. I didn't have the benefit of this drawing when we started working on the building in 1999. It was unearthed by an architectural historian, Elizabeth Shooton from UCD, when she was doing research in London in the Institute of Civil Engineers, and she came across this drawing. This drawing was undertaken by the son of Charles Rennie, who was the designer of this building. George Rennie did this sketch before the building was constructed. And this is the building as you see it today. You have these, at the north end of the building, the end just beside the Lewis there, where it's got this hipped ends on it. And the southern end of the building in 99 looked like this, where it didn't have any hipped ends on it. So it did originally look like this on the northern end as well, but it was cut back sometime around the 40s and 50s to allow a wider road to go past it. You'll also see two great big doorways there on the end, and I'll come back and talk about those later on. But this is the condition of the building when I first became involved in it just over 20 years ago. When we get involved in buildings, we look for all available information, all historical information that we can find. And this was a map that we found in the British Museum. And this is a fire insurance map that was generated for a lot of the big cities throughout the UK and Ireland. So these existed for Dublin. And here what you see in the middle of it is you see CHQ. And you can see the cross walls through it, which it's items like that we can see in the building, that you can see pick up little bits of history and what happened. So we know what the building was like in 1893, that it had two cross walls and was divided into three sections. And when I became involved, this was the only drawing that we actually had of the building. And this drawing was drawn 100 years after the building was built. It was drawn in 1927, and it was in the archives of the building owner at the time, the Custom House Development Authority. What you can see here is a plan of the basement vaults. There's 72 basement vaults, and it had some dimensions of them here. And on the right-hand side, you'll actually see some sections through tunnels that are underneath the building or to the side of the building. So the large one right on the right-hand side of the drawing, beside the writing for 1927, is the one that's up on the very top of the drawing. And that's so big you can walk through it. And I know that because I've walked through it. And on the drawing, it says that it's 3,000 feet long. Now, it's not 3,000 feet long anymore, but it was at the time. And it goes, what it does do is it takes rainwater from this building plus the surrounding buildings, and it puts it into the Liffey. And I'll tell you a bit more about that later on. This was the condition of the building when I first came in here. I was here in 1996 for a while for a visit, but these are a series of photographs to show what the condition of the building was like. A pretty sorry state, water coming in, mold everywhere. You see again more photographs of mold here. And this is it, with large openings through the building to allow trucks to drive in, would you believe? Another image of the building in its sorry state. This is actually the northern end of the building. So what you see, the dark section in the middle there, is a doorway, which is the current access in and out of the building to the Lewis line. Here again, water coming in. And what you see here on the right-hand side, the bottom right of the photograph, you see cars parked inside the building. So when I came here in 1996, first of all, this was a big car park. You could pay a pound to park your car in the building for the day. This was it when we started work on it straight away, and it had all these strange things. That the symmetry was lost in the building. You see these two odd-shaped windows here that were installed in a blind window. A window was a window that was made to look like a window, but in actual fact there was brick in it. They did that because they were putting whiskey and tobacco in this building. They didn't want anyone to rob it. But when they put in a mezzanine floor about halfway up, they actually put glass into it in two places. So when we started working on the building in year 2000 to renovate it, we came across all of these strange kind of entities that you had here in the building. Here again, a patchwork quilt of various different things. They bricked up various openings in at different times with different bits of brick. And what we really wanted to do here was to bring it back to its former glory, the way it was when it was constructed initially. So this is an image just after we started work in 2001, when we took out the cross walls that were going down through the building. And this is where you can see from one end of the building to the other end of the building, first time in about 140 years. And this is a cross section that's through the building. So it shows the vaults underneath, and it shows the structure up above from ground floor that you'll be familiar with if you walk into the building here. And you see the cast iron columns holding up the roof ironwork that you see here in these what we call queen post trusses. So you see there's 8 vaults all the way across. They're called barrel vaulted vaults, and then you have 4 bays up above as well. So there was a lot of symmetry here with it. And then on either side you have these various tunnels, service tunnels. One of the most amazing things about the building are referred to the culvert or the tunnel on the left hand side that you could walk through that was used to take away rainwater. And if you look at the groundwater level here in the building, the groundwater level is while it's below the building itself, the River Liffey level is well above the lowest level of the basement here, the basement vaults. However, it is always bone dry, water never gets in, and it works very, very well. And it's a testament to the original design of Victorian engineering that they did on this building. The culvert I was referring to, this is when we were doing the works in 2001. You can actually see the top of the culvert was exposed. We were extending out to the Western Glazed Conservatory, which I'll talk about later on, and you can see the top of it there. You can see the hole into it, which we hit by accident because it was we thought it was in a different place on the record drawings than what we actually found when we started digging. And this is it again, and what you see in the drawing or in the photograph here at the front, you'll see a kind of a vertical shaft there, which is actually a manhole. That manhole is how we used to get into the culvert that it still exists today. There's a manhole on the top, and it's too steep. You have to be lowered down. It's too steep to climb down a ladder. You have to be lowered down by a winch into it down below, using breathing apparatus as well, because there's lots of noxious fumes down there, and there's actually quite a few rats as well. And here again, this is the top of it, just at the location I'm saying that we broke through when we were building right beside it. And this is it when we actually drew it all. So it's in blue there. It goes from the back right underneath the Lewis line, goes out underneath the road and discharges to the Liffey. And as I was saying earlier, this is underneath the level of the high tide of the Liffey. So this is actually an image from inside it, and you can see the beautiful cut stone as the water was actually going out to the Liffey. And what they had up until about 20 years ago was cast iron flap valves on this, so that when the high tide came in, the tide actually closed the cast iron flap valve and shut it tight so that the Liffey couldn't extend up through the building and flood the building. And then when the tide went down, of course, the water that was stored in the culvert then had a greater pressure than the water of the Liffey, and the water flowed out and was able to escape that way. So it acted as a big reservoir when there was high tide in that. So a very simple device, just a very simple moving part, and made it work. So to go back to the original drawing that we had from 1927, you see the 72 vaults here. The first time I came into the building in 2000, every vault looked like this. Every vault looked the same. They were all whitewashed. And I got completely lost in the building. I felt like I needed some string to get myself back out of it. Fortunately, someone had painted numbers on the vaults as well a number of years ago. And I was grateful to find these fire exit signs on the right-hand side, which at least gave us a bit of an idea how to get out, because there were 72 of them and they all looked exactly the same, and it got very, very confusing in there. Now, this is what the vaults looked like in 2000. And to describe what this looks like, or looked like at the time, or how it worked, is that If you were storing whiskey in this vault, you only wanted to wheel the barrels in and then store them to the sides of it. So you see the kind of the flat walkways through the middle of the building, through the doors there. That was used to roll the barrels of whiskey in on. And then you see these pair of parallel rails, it looks like, on each side, down each side. Well, that's what they then put the whiskey barrels up on top of, so they'd be up off the ground. So you have these flat flagstones, but underneath the whiskey barrels, there was no need to make them as such fancy flagstones as that. So what they are is actually, they're just beach cobbles, rounded pieces of stone that probably young boys collected on the beach and then sold into the building site to be put on the ground there. So when we came to renovate and refurbish the building, we left as much of this as possible underneath. So most of this is still underneath the basement vaults. So if anyone ever wants to dig it up, it's all still there. And here is the building as we started work on it, and you can see that you can see from one end of the building to the other, and you can see all these remnants up at high level of bits of brick in places, and you can see the colors that people painted on the columns over its history. This is an image that was in the Times Illustrated magazine, I understand, in 1856 of the building. And it was an engraving that they did at the time, and the Crimean War had just finished, and 3,000 Irish soldiers had come back to Dublin, and they wanted to thank them somehow. And they didn't have a big enough space in Dublin to hold an event except the CHQ building. So what they did is they emptied it out of all its goods, and lots of local grocers and restaurateurs and hotel owners contributed lots of food as a thank you to these Irish soldiers, and they had a big banquet, and the paper details all kinds of food that they ate and how many of this and how many of that and how much they drank and all of this. And this is quite an interesting engraving because it gives us a snapshot of 1856 and what the building looked like. And I'll come back to this later on because it gives us some historical clues of what actually happened around at the time. So again, going back to the building and just looking at the quality and the detail of what you see here on this drawing, that it went into tremendous detail of how everything was going to be put together. And this was before the building was built. And I'll show you a little bit about this as we go on the building. This was an image that I took just before we demolished the cross walls. And you can see there was an old staircase that went up to a mezzanine floor that someone had inserted over the years. And we took that down. So I remember the day that the final section of the cross wall came down in 2001. And I came down from my office specifically to see it because no one had seen that view for at least 140 years. So I really wanted to see what it looked like. So we know from the Crimean War banquet photograph that in 1856, the cross walls weren't there. And we know from the gold map from 1895 they were. So we know it was sometime in between there that the walls were definitely built. And so I knew it was at least 140 years before someone had seen this view. So I really wanted to see it and photograph it. So going into the character, what we saw with this beautiful cast iron and wrought iron roof, this was the first time this was ever done. And it was the first time that a building of this nature had been constructed without timber in the building at all. And this was something that the designer, George Rennie, and his father, Charles Rennie, had actually promised the Dublin Port and Docks Board that they would do a building that was completely timber-free. And the ironic thing then is that they then went and stuffed the building full of tobacco and whiskey, which is the most inflammable things you could possibly do in the building. But this was their starting point, and they actually did it. They actually built a building with cast iron. So these are some photographs of the condition of the building when we saw it. And you can see the layers and layers of paint that no one ever took paint off. They just kept putting more on. And you can see the paint flaking off at the time, and you can see the condition of it. This is an interesting just little aside that this is a rainwater pipe that is integrated into the design of the building. You would hardly notice this. This is a photograph taken from up at high level looking down at it. But why I wanted to show you this is that if you ever get a chance to come into the building, what you'll actually see in the building is while all the columns look to be exactly the same, they're not exactly the same. The column on the left is an 8-inch diameter cast iron column. The column on the right is a 12-inch diameter cast iron column. So the one on the right contains the rainwater pipe for the building and the internal valleys there. And what's different about it is it doesn't actually really contain a pipe. What they did is they made the column bigger and they made the center of the column hollow, which then means that you don't have a pipe within a pipe. You just have this big, thick, solid cast iron section. And it's quite an incredible feat to think that this was cast 200 years ago, how they could cast that with a hollow section all the way down through the middle of it. To this day, if you asked someone to cast that now, I don't know if you'd be able to make it. All that art has been lost, well lost. These are some images of the building as we started to do the major renovation. And what the major renovation involved really was stripping off all the slate tiles and storing them and trying to reuse them, and stripping back all the original paint from the building and doing what we call shot blasting all the rust, all the particles and mold and everything that had stuck onto the building over its lifetime, and getting it back to the bare original metal so that we could then paint it again, and it will be good for another 50 years after that was done. So in some locations, you can see that the quality of the original cast iron and wrought iron work is still there, and there's no paint on it, but you can see that wrought iron in particular and cast iron is very good at resisting rust. So it rusts a small little bit and then it stops at that, and particularly if it's dry and well ventilated. So you can see some examples here of cast iron that has not been touched at when the time of this photograph was taken in 180 years. Here's more of it here, which has suffered more. You can see on what we call, these were called the slating battens. These are the battens that the slates were fixed directly to, and you can see what we call fish bellies on these purlins here. That mimicked where the forces were going to be exerted onto these. So this is quite a feat to have achieved 180, 200 years ago, and so many thousands of these replicated. And this was, I suppose, a photograph that we took just as we were renovating it, where we divided off the building into different sections with plastic sheets so that we could shot blast in one area and work away in other areas. So what you can see is the basic cast and wrought iron work here of the trusses, and you can see the slates that are straight onto the slating battens in places there. So you're looking at the underside of the slates. The biggest problem with that is that, first of all, it gets very hot and very cold. And if there's a hole in a slate, well, the water comes straight in. So I'm sure back 200 years ago, it was someone's job just to constantly go around repairing slates that had broken and failed. This is a kind of a funny photograph that you see. In 1995, there was a lot of work done to try and move the renovation of this building forward. And the work that they did is they actually did a full-size sample panel of a whole bay, which was, they were looking at different colors of the steelwork. They were looking at how best to renovate the roof on this to try and get some insulation in. And they were looking at how to take the existing paint off, various things like that. So what you're actually seeing here in this photograph is you're seeing in the foreground a sample of the 1995 works, but then in the background you actually see the condition of the rest of the building in its state at that time, with the mold and the old lead on the paint and things like that. So it's just a nice snapshot of what you see. This is it again, part of the sample. So this is exactly what we worked with, and we said that sample is perfect. Let's do that on the whole building. This is the works halfway through, I suppose. On the top part of the lantern here, you can see that the slates have been removed and, have been replaced. You can see the new lanterns have gone in, and you can see at the lower level there, you can see the kingspan sheeting that we're about to put timber battens on to put the slates back onto. So ironically, after 180 years of this building having no timber in it, we unfortunately had to put timber back into the building in order to put the slates on it. So that's the one regret I think everyone on the design team still has. All the lead work was replaced and completely renewed after being there for 180 years. It just had gone long past its sell-by date. And to explain the servicing strategy of the building, because we wanted this building to last a long time into the future, so it had to be able to be flexible and adaptable and be able to accommodate shop units or various things that could happen throughout the building without having a situation where we would have to bring in cables or have pipes up around the floors and things like that. But we were also very conscious of the fact that we wanted it all to be hidden and concealed. So after a lot of talk about it with the client and with the design team, the strategy that was come up with is that on the east side of the building It was the side of the building that people didn't see, and that was the side we should deal with servicing. But throughout the building, we wanted it all to be concealed. So we had a very thick ground floor over the vaults. So the strategy we came up with was, let's use that ground floor to transfer services underneath people's feet as they walk on it. And it can link both upstairs around the place and downstairs as well. So what you're seeing here on the left-hand side is a whole series of pipes we're about to connect together. And on the right-hand side, you'll see an air duct. And I'll explain that a bit further now in a minute. So this is a cross section through it, and you can see the cast iron work above. So right through the middle of the drawing there, you're just seeing ground level, and you're seeing a whole series of ducts and pipes. And what you're seeing there as well is right in the middle of each of the vaults, there was 4 what we call lenses. And the lenses were original to the original building. And we believe they were there to allow some light, and they had a grate on them. And they were to allow some light into the vaults underneath when the guys were rolling in and out the whiskey barrels, because they didn't really want to be bringing in naked flames with so much whiskey around. So the idea was that we would reuse those since they already existed. And what we would do is we'd create this duct that went from one side of the building to the other side of the building. And what we could do is we could put air in on one side of the building from one vault, and that same air would come out at the other end of the building, all through the vaults, and that no one would see it. And then what we would do is we'd actually put a lid over the top of the duct, and no one could see it. So this is it during construction. So you can see the trench going from one side to the other side, the air duct, and you can see the original 1820s lens that goes down into the vault below. So we're just about to cover the top of this, and there'll be a concrete slab put over the top of it that then people would walk on. And the idea would be is that they don't even know it exists underneath their feet. And this is a photograph taken of the entire building going down through it, and it's just ready for concreting. And that's a whole series of ducts that are about to be concreted in place for them never to be seen again. And then there was a couple of awkward situations, which are down near the north of the building, where we had staircases to accommodate. So we couldn't just go straight across. We had to kind of do a few swerves here and there. That's what you see in this photograph. So all of these air ducts went to the eastern side of the building, which wasn't the best looking side of the building, because there had been other buildings built up against there over the years. We also knew from some of the research we had done. So what we were trying to do was trying to bring all the services over here. And so what we decided to do was build a basement on that side of the building, on the east side of the building. And these are some of the photographs taken during the construction where we were digging down. And what we found when we were doing that is that they had these flying buttresses, as they call them, which allowed the damp to be kept away from the side of the building. So you see the kind of the dark triangle on the left-hand side of the building there. You could actually crawl through that. And the idea behind that was to stop damp touching off the building, because back in 1820, they didn't have products like we do now to keep damp out of buildings. So they had to do with natural means. So they had gaps like that and they allowed the air to blow through. It's any damp that got in, it evaporated. And here again is a photograph from the other side. And you can see on the right-hand side here, 2 big openings. They were openings that we just put in at the time to allow air to come in and out of the building in that way. And the idea was that we would then bring it up through chimneys. This was one of the basement openings at the time, and you can see we were just taking down the brickwork. You can see some of the bricks still there at high level built into the doorway that had been bricked up for 100 years maybe, and we were just trying to open it up. And here it's one of the doorways that we didn't reopen, but it was up at ground level. This is on the east side. So what you can see here on the east side as well is you can actually see the chimneys, and you can see the grills in the side of them. So if you were down in one of the vaults in the building here, having dinner or having a drink in Ely, say, or Urban Brewery, you'll be getting fresh air that would be coming through these chimneys. So to talk a bit about how we renovated the building and how we took the paint off it, this was it as we put up the scaffolding to cover the building, because as we were trying to what's called shot blast all the paint off the building, as we were shot blasting the ironwork, what would happen is the shots would combine with the paint and then cause it to come off the ironwork and then fall to the ground. But some of it would go a bit airborne, so we had to encapsulate the whole building in big marquees. And when we would go in to inspect, we couldn't go in for at least an hour and a half after they had finished work, because there would just be particles everywhere in the atmosphere. And I don't actually have any photographs during the process, because any photographs we tried to take just had all these particles floating in the air. It just couldn't take any photographs. So what we were trying to do was take off all these layers of paint and get it right back to the bare metal. So in order to do that, we effectively had to set up a painting factory and a shot blasting factory on the site. Up at high level, there was hundreds of these lanterns and thousands of little panes of glass up there, but some of them were in a really bad state. So all the research that was done in 1995 by the architects, Michael Collins architects, and particularly Michael himself, really just said that these were a lost cause, and that there were some problems with the detailing of these lanterns in 1820, and that they allowed water in. So it was decided that there was really no hope in trying to salvage these lanterns, because they had corroded for so long, that the best idea was to remake them. So they were completely remade, with slight modifications to them to allow them the detailing to be better. Like you can see the sills that are put on them at the bottom to allow water to shed off them and that. But they were made by a foundry in Scotland, because even though I think there was some research done to see if we could find the original foundry who made them, but it was long since closed. And then they were brought to Ireland and painted in the building here, so that the color match would be perfect with it. So you can see a kind of an assembly line put up where they have these guys hanging off scaffolding, and the same painter who was just painting the columns, the particular gray color, was also painting the lanterns here at the same time. And then what we did is, in a lot of places, all these pieces of the building, they were all held in places by wedges. And so it was easy enough to dislodge them. And since they were all replicas of each other, thousands of them, the idea was to take them down, put them on the floor of the building, shot blast them, paint them there and then put them back up. There was never a question of taking them off site. That's how you lose things. So you never let them out the door of the building at all. So these are some examples. These are even before they were cleaned. And in technical terms, we shot blasted the ironwork back to what's called SA 2.5, which is a good standard that then it's got plenty of grip on the surface, so that when you paint it, the paint will stick to it. And these are some examples of it underway and going together. And this is a shot of the factory system in place, with thousands of these slating battens and rafters and purlins being all shot blasted and painted and ready for putting back up again. And this is some of them going back up again, and you can see the detail. Like these photographs we took just when we we're putting it back up again, before slates and panels went on it, so you could actually take photographs of them, and you could see clearly how it all went together again. So you can see the beautiful level of detailing. And not forgetting, this was made 200 years ago. And the quality of this, these are images of just the joints, and these are really similar to the details that were drawn by George Rennie in 1818. You can see the sky in the background here, but you can see the way it all went together, beautifully detailed. And you can see here quite simply the way they put it together, that you had two rods passing each other through a receiver that was on the other end of it, and then you put a wedge through and hold it all together. And it's beautifully simple, but worked incredibly well. And again, here it is. You could see this was actually taken inside the canopy, the marquee that was over the building. And this is it with the kind of the final pieces going together. So what you have, you can see the lantern is back in place there. You can see the underside of the Kingspan sheets with some insulation in it there in white. You can see everything painted, and you can see it all going back into place. And then a couple of fellas got a job for about a year to put glass into each one of those little lanterns. I think there was thousands of little panes for it. This is actually on the north end of the building, right beside the Lewis. You can see how complicated and how unusual this piece was compared to everything else, where you had the hip rafters at the end again. So I find this incredibly complicated, how they were able to come up with this and make it, considering we have trouble these days in trying to do such 3D elements like this, and we use a lot of fancy 3D software to do it. They had nothing like that in their day. So it just shows how amazing this even was to be building this in 1820. Again, one of the details I was talking about earlier, the way it all goes together like a home mechanic kit. And to zoom in on one of the sketches from George Rennie in 1818 and the finished product here on the left-hand side, it's just similarity is great, isn't it? And this is where I was referring to earlier. We're just finishing off on the top of it here, and this is where the timber battens go back on, much to our distress. So to talk about an insertion that we put in 2001 to change it into a usable building, we put in a mezzanine in 2001. So this just tells a little bit of the story about putting in the mezzanine and how it worked. So the mezzanine is an intermediate floor, because as itself, if it was open all the way up to the roof, it was just far too high. So the idea was to put in a mezzanine floor. So what we decided to do was, rather than use the existing cast iron structure to support the mezzanine floor, we put in a completely separate structure to it. And there was a number of reasons we did that. One, we weren't sure what load each of the original columns could take. And also under the Irish building regulations, if we were to actually support it off the original cast iron columns, we would have to fireproof the cast iron columns. So what we decided to do was leave those columns to support a roof structure, and to put in a new structure itself that would support them, which is what we did. So it's a completely independent supported structure. There's no cross bracing or anything like in there. So that's one of the reasons why the beams are quite deep, because they help with to stop it falling over. And instead of using cross bracing. So we inserted these mezzanine constructions throughout the building, so that these actually create the shop units. And now they've been turned in, those mezzanine units have been up above them and turned into the Dogpatch Labs and various other uses up there. This is it nearing completion. You can see it's a steel and timber construction, and we kept it very simple and lightweight because we didn't want to put too much extra load on the building. And this was in 2001. And you can see from one end to the other end of the building, just this huge big space, which at the time we didn't really have a use for, whereas now it's used. I think there's probably 100 people work up there every day. To talk just a little bit about the service corridor at the back, the service corridor at the back had to be a fire rated corridor. So rather than go with lightweight materials, we actually went with a concrete block wall with a concrete deck on the top of it. And just what we were trying to do was minimize the interventions into the existing building so they could be reversed in the future, which is a good principle of conservation. So all we have is we have an angle that's bolted into the original brickwork on the right hand side. You'll see a detail of how that works. So there's just a bolt is the only thing that connects it. It supports the new slab. And then we pour the concrete on the top, and that provides the fireproofing. If we ever want to take it out, we can just take out the concrete, and we just have the angle there looking at us, and we can unbolt the angle, and we just have the bolt interfering with the existing building. And this is a photograph of the corridor in place as it is today. And what's actually the case here is that all these services that are in that space there are all suspended from the new structure that we put in, not bolted in to the original historic wall. So the idea is that we were able to service the building again by leaving the original fabric of the building intact. In 2016, as part of the Epic Museum fit out that we worked on as well here, we took out some of the block wall. And here is just an example. We were able to alter the block wall and put in a steel corbel that would then support the building, the mezzanine roof, the concrete roof up above. So we had designed it so it would be adaptable in the future with minimal interventions. So to talk a bit about the south elevation of the building, which is the one that you have see on your way in now. This was the original 1980s image that I showed you earlier on, which has the two doorways in it. And those doorways, unbelievably, were used to drive trucks in and out. And I'll talk about that a little bit later on as well. In 2001, the architect responsible for the building at the time and the renovation of it, Michael Collins, came into a meeting in the Dublin Docklands Development Authority one day, and I was in that meeting, and he said, I have an idea for the south facade of the building. And he said, I just want to slice the end off the building, and I just want to put up a sheet of glass. And everyone said, that's a fantastic idea. And how are you going to do that? And he said, I don't actually know, but I think it's a really good idea so that people can look in and see the building from the outside without going in and see this fantastic structure of the vaults and also see the end of the roof trusses. So Michael said that he knew someone who may be able to help with design of this, and it was a person by the name of Tom Gray. Now, Tom Gray is an Irish architect based in Paris. And at the time, Tom was working for a company called Aura 4 that was set up in 1976 by another Irish man, Peter Rice. And Peter Rice had worked on some amazing buildings like the Sydney Opera House and the Pompidou Centre and various real cutting edge buildings. And he'd done an awful lot of work in glass. And the company Aura4 in Paris specialized in glass. And for an architect, Tom knew a huge amount about structural engineering. And I often admitted probably more than me. And Tom was brought in to engineer this facade and to see how we could come up with a solution that would work for it. So Tom said, yeah, I can make it work. I can support the glass, but I need the base bill engineers, which was myself. And at the time I was working for Arab Consulting Engineers. And they said, well, you have to support how Tom is going to hold up the glass. And we said, yeah, we can work with Tom and we can get that to work. So I'm going to explain to you a little bit about how we've done that. So this was actually during the works when we're cutting the end off the building. So the end's gone off the building, we weren't too bothered about taking the end off because it had only been put up in the 60s when they widened the road. So the idea was to cut back the building. So we cut it back and you'll see the columns left there. And then the idea was how are we going to support this? So Tom and myself had this discussion. So what Tom said is, he said, I want to extend cables from one side of the building to the other. And I want to pull them really taut. So they'll be like elastic bands. They'll be like very strong elastic bands. And I want to pull them very taut. And then when the wind blows against them, the glass that's attached to these cables won't move because the elastic bands are so taut. And I said, that sounds good, except I have a problem with that because I've got to support the ends of the elastic band. And that's where we started discussing how I was going to do that. So we were responsible for the two dark posts that are at either end of it. And Tom was responsible for the elastic bands then across the middle, which are diagonal lines across the middle there. And then I had to support those so that to stop the elastic bands compressing in on each other. So that was the idea so I said to Tom, we'll manage that, there's no problem. And then Tom said, oh, but I want to do it all the way down to basement level. So I need to extend it all the way down to basement level. And that's when I really started to get worried and started to say, Tom, these are enormous forces we're dealing with to do this. So I said, is there any chance that we could put something through the middle of it that would really help us instead and reduce the force? Like if we could put a beam through the middle like this that would hold the elastic bands apart and would really help with it. And Tom was saying, no, that really won't work because it will interfere with where the glass line is supposed to be. So we don't really want to do that. So is there any other way you can do it? So then I thought about the geometry and the whole way that we were trying to create this kind of opening on the outside. So part of it would be outside so that you could walk along on the footpath and look down. And I said, well, maybe we could try and extend it in such a way where I can still put this beam in the middle that holds it apart, but we can move it away from the glass. So the glass is actually seen and open from top to bottom. And Tom said, yeah, I can work with that. And we said, yeah, we can get that to work. And then thinking about it a bit more, instead of having big foundations at the bottom trying to hold it apart, by putting in another beam, which was the green element at the bottom, what I could do then is I could actually hold apart the bottom of the props as well, of the posts as well. And the idea would be that we'd hold the whole thing apart. So Tom was then able to put his 5 or 6 elastic bands under huge pressure all the way across, and we then would hold it apart. So that was the theory behind it. And then we had to put it in principle the way we were actually going to do it. So here's some photos of the work as we were doing it then. So what we did is we took the end off the building, we took it all the way down at basement level, we put a slice through the building, we cut through those vaults. And then instead of having just a single elastic band or a single cable across the center of the glass line, what Tom decided to do was to separate them a bit from the glass so that we'd have the glass purely going up through the middle. And the idea was he wanted it to be as transparent as possible. So it's a sheet of single glazing, which has a clear silicone that links each panel of glass. And then he wanted the glass to be as transparent as possible. So we got a special low iron glass, which at the time was only available in America. So that's what was the glass that was used on it to make it as transparent as possible and not green or anything like that at all. So the idea was to hold these cables, these elastic bands apart. So he put in these 3 columns, but they're actually like trusses that they hold the panels apart to make it even look lighter than it is. And that's what goes horizontally. So the elastic bands go horizontally across the building, which is 50 meters from one side to the other side. And just underneath the railing on the left-hand side, you'll see one of the beams that we put in that holds the elastic bands apart and stops them trying to collapse on themselves. The other one is on the right-hand side, just above the arch that you see on the right-hand side of the top of the vault. And here, this photograph is taken just when it's finished, and this is above the, right above where the other beam is that goes from one side of the building to the other side of the building, again, propping and holding the elastic bands apart. This is us doing the works. You can see we had to prop the building as we were doing it, putting in the reinforcement there. We're putting in an air duct underneath it as well there. And the purpose of the air duct, you can see it on this photograph, which is a finished photograph taken at the basement. So it's taken between the vaults and the glass itself. And you'll see this grill all along the bottom there. And that grill leads to an air duct. So we can pump warm air in on a cold day up along the facade, and it goes back into the building and it keeps condensation off the facade. But again, it's all hidden and all concealed at that end of the building. This was a photograph taken during the actual construction cutting back of the building. I just found this interesting because we could have sliced through the building. We can see all this builder's debris that they threw in there in 1818 to 1820 before they infilled the whole back of the building. So you can see bits of broken stone thrown in the top. So it's effectively rubbish, and they didn't take anything off site. But it's just interesting to see history just there that's been buried for 200 years. This is a photograph that I wanted to talk about a little bit, because I did show you earlier on that there's two large doorways that went into the south elevation of the building from the quays, and they were used to drive trucks into, articulated lorries, 40-foot lorries in. But the level difference between the street outside, the quays outside, and the building is about 1 meter. And so they had to ramp up from the road up to the building. So how they did that is they actually broke out the vault and put in a concrete ramp. So you're seeing here the remnants of the concrete ramps that we had to take out. So it was quite easy to take it out, but then we had to rebuild the original 1820s vaults, which was quite interesting in itself. So here's another photograph of the ramp, the second ramp there, which is the flat ramp. So we set about rebuilding the vault. So that was an interesting process where we were trying to mimic how they would have built it in 1820. So we used the same techniques that they have done then, and we can see this in various other vault structures around. We can see exactly how they did it. So what we did is we put up a timber arch and then laid the bricks on top of that timber arch and then infilled on the back of it. And then we took down the timber arch, and then we had the vault. And to this day, when you go out there, it's very hard to see the two new vaults that were built in 2001 and weren't built in 1820. You can see it during the works there. You can see some of the new brickwork going in. And this is a photograph during the works. And on the left-hand side there is Pat Irwin, one of the architects from MCA Architects at the time, inspecting the work in progress. And just above the vaults there, you'll see one of the beams that we put in to hold apart the glass that's supported on those cables, those elastic bands. And this is the finished product. You can see here on the left-hand side, you can still see some of the props for the newly rebuilt vault. So the stonework that you see there, while that wouldn't have originally been there, it is stone that we salvaged from the small sections of demolished vaults that we just took down there. So none of that stonework came from anywhere else. It's always been there for 200 years. So the idea is we just reused it. So there were some parts of the building, like this is the southwest corner of the building, that just had been I suppose riddled with holes over the years. You can see on the bottom right-hand side, it looks like windows from a toilet or something like that. And the top, it looks like an office. And some of these walls were just too far gone that were very difficult to repair. We tried to repair them at the time, and the brick matches were just very hard to do. So this is actually what you see at the moment. It was intended as a kind of a feature wall to put names on and things like that and displays. So that's why it was left like that, rather than trying to match up with or even demolish more of what was originally there. Some of the works that happened at the time, if you go into the Epic Museum, you go down a glass staircase. We put that in 2001. So this is the opening that we were forming to put in the glass staircase. And this is the staircase in place now. The idea is that you walk on glass treads on it, and there's a glass lift beside it. So the idea is that you're actually able to get as much light down into the space, and you can see the history of the building that's there. This is the end of the south elevation above that south wall of glass, and this is just connecting or finishing off the top of the lanterns and the slate there as it matches up with the glass. The idea is just closing it off, and this is just during the construction of it. And this is it, literally finished. It hasn't even got the hoarding taken down on it. So this was just the end of 2001. These are some photographs that we took just when it was not open as yet, but you can see it on just about to be opened. So I just have a couple of little anecdotes to finish with on the building. This is the Sean O'Casey Bridge that's located opposite it, and quite a lot of people comment about why the bridge doesn't line up with the main mall of the CHQ building, and there's only a few people know the story until I'm going to tell it now. This is the building as it lines up. So it does line up with the second bay on the right-hand side. And when you look at the building itself, the mall is on the second bay on the left-hand side, which is at the bottom of the drawing there. And the reason for where all this came from is that for a long time, when we were looking at this layout of putting in the mezzanines, the central spine down the middle that the public would walk in was actually closer to the top of the drawing you're looking at on the screen than to the bottom. Until one day, the project manager for the DDDA, Grania Hollywood, came in one day and said, I have a better idea. I think we should move it to the bottom. And everyone thought about it and said, yeah, actually, that's a really good idea. So this is what we built, and we moved it to the bottom. But what unfortunately happened is nobody told the bridge designers who were in the process of actually building the bridge. And therefore, the bridge ended up in its original location that had always been planned. So that's why when you come across the bridge at the moment, you have to walk to the left to get into the building. And just to go through a little secret that I discovered over the years on the building, all is not what it seems in this building. Going back to a little bit of history, when we were doing some research on the building, came across that actually George Rennie and his father had also worked on another building at the same time of a very similar nature in West India Docks. And in this building, it was similar because it had a basement vault. Now the vault construction was slightly different. They're using groin vaults, which means there's kind of columns there instead of walls. But then above it, you had cast iron columns. You had the same kind of shape of roof truss, except in this drawing, you can see it's in timber, and it had the same lanterns up above and the same kind of queen post truss, even though slightly different kind of cross bracing and that. And this is the drawing that George Rennie had done in 1818 as well, around the same time. But when researching a little bit more on this building, we discovered that within its first month of construction, using cast and wrought iron roof trusses, there actually was a collapse in the West Indian Docks. And the client at the time decided that he didn't want to use cast iron because it was really a brand new material, and he wanted it to be used in roof trusses, even though it had been used in arches in railway construction for years at that stage. So he told them not to continue with the wrought iron or cast iron roof trusses, but actually to build it in timber. So this is a record drawing of the West India Docks from the time 1820 or so, but you can see that the roof truss is in timber, not in cast iron. However, George and his father, Charles, decided not to tell the Dublin Port and Docks Board about the incident in the West India Docks, and they proceeded with their design for the Stack A structure, the CHQ building, which is what we see here at the moment. Now, it's been in place 200 years, so I wouldn't be overly worried about it. However, when we were doing the work on the building, I was up on the scaffolding one day inspecting some of the finished structures. And I came across, and you can see it in the image here on the bottom right-hand side, you can see a crack in the cast iron beams here. And I got a little bit concerned about this crack. So I decided to go looking for more. Now, the cracks themselves are very hard to find. So I started going around with a hammer, and by knocking on the cast iron, you could hear by the sound of it, if there was a difference in sound, you knew the two pieces weren't connected. And I started to find quite a lot of these cracks. So I started getting a little bit concerned about it because there was no signs of distress in the building. There was no signs that anything was amiss. So then we started to look a little bit more about how the building was put together and how the way that the structure was put together. So what you see here is the column at the bottom, the circular column, the casting, and on top of it there's a capital, which is the square section. And the way it appears the building was done is that these curved cast iron arches which there's a huge tradition at that point of building railway arches in that. So what they did is they got these curved arches and they slid them into a slot in the top of the square cast iron capital. And the idea was that they were all wedged in there and the whole thing was held in place. And that seemed to work fine. And then what they would do is the trusses would sit on them at third points, and that's fine. What I think they missed in it, and this is what happened with the cracking, is you see here on the left-hand side on the original drawing on it, you can see in this one in London, you can see the same kind of cast iron trusses here. And what you can see is you just see the cast iron trusses. That's all you see, and they're supporting the trusses. You just see the cast iron arches, and that's perfect. And that's what we should really be seeing here in the CHQ. But as I started to think about it a bit more and started to realize what was happening with the building was very, very long. It was 150 meters long. And we wouldn't build a building 150 meters long these days without allowing for thermal expansion and contraction. So when the sun shines on a building, it heats it up. And this particular building, what they had done with it is they had covered the whole thing with black slates, and there was no insulation on the inside. So what was happening is when the building heated up, it started to expand. And when it cooled down, it contracted. So what we think is over the years, what happened is the building expanded and contracted, and then these cracks started to happen. And as the building started to put itself apart, because it had no allowance to be allowed move. And one of the things that struck us about it was that this detail itself seemed to be a little bit of an afterthought, because you can see here, you can see a kind of a cradle where this diagonal member seems to sit in on the truss. And then there's another tie rod that goes across. And this just didn't seem right. And the thing that really struck it for me was that everything about this building is so meticulously detailed and it's perfect and everything has its place and everything is extremely curved and well-rounded. And then if you look at the bottom right-hand corner of this photograph here, what you see is these two diagonals that are coming up. And these two diagonals seem to finish at the bottom, whereas as they launch themselves off the top of the column at the bottom of the capital there, they seem to, be a kind of the bird's mouth detail, just doesn't seem to be as well thought out and well crafted as anywhere else in the building. So to me, it seemed like a bit of an afterthought. And as we looked a bit more at the building, I started to realize what had actually happened is that when they discovered that these cast iron trusses were cracking because they hadn't allowed for expansion and contraction, what they decided they better do is put in some remedial works. And so what they did is that these diagonal props are actually remedial works, and the cradle then that supports the trusses are an afterthought, and that they support them and they take the pressure off the cast iron beams so that the cast iron beams can crack away and is not actually a problem on the building at all. So this is it. You can see it straight on here. You can see the two diagonals that support the building, that support the trusses, and the cast iron beams that would originally have supported it no longer support it. And if we go back to the Crimean War banquet image in 1856, we can see these same diagonals. It's quite hard to see, but you can see these same diagonals up in the top corner of the image here. So we know they were in place then. So we actually reckon that they were in place for quite a long time, from within the first 10 years of the building being constructed. So as I was saying that we have these diagonals throughout it, one of the things we did in 2001 as well was install a glazed elevation on the eastern elevation of the building. And at the time, London-based architect Fitzroy Robinson had been asked to do some work on the basement, and they came up with the idea that the only way to get people into the basement was to build an extension onto the building. So they decided on a glazed elevation, but nobody really had any ideas how to do it very elegantly. So Tom Gray was called on again to see did he have any ideas to do this glazed extension. So Tom decided to take inspiration from what he saw inside the building to do this glazed elevation and try to come up with ideas that were similar in kind of style and thinking to what happened inside the building. So this is an image of the finished product, and this was it during construction. So you can actually you see on this image, you can see V's in the building supporting the trusses. So what Tom was doing was he was copying the style of the diagonal members inside. But Tom didn't have the benefit of realizing that they were a retrofit to fix a problem that was inside. So he used the inspiration of what he saw inside, but he didn't realize that they were not part of the original design of the building. These are just some sketches of what Tom, working for R4, did at the time. So it's a very lightweight structure. You can see the V's that take the inspiration from inside, and you can also see the V's support the trusses from inside as well. So it really continues on the language and style of what's inside. And this is it. You can see how lightweight the whole structure is from inside. And this is it from the outside. This is the entrance door that you walk in, and you can see Tom has also concealed the rainwater pipes that come down behind the columns, and you can see the whole style is taken from inside. And these are some photographs during the works. And that is the final slide. And this just shows an image that was taken in 2001, just after it opened, with the lantern that was specifically designed for the building. And it just shows the elevation, the south elevation shows how clear it is and shows it all the way to out across the Liffey. So thank you very much for listening. I hope you enjoyed it.